All right, we're back and we're going to talk about some retrieval cues for a few minutes. What are they? They're reminders of information we could not otherwise recall. They help us or cue us to pull out memories that obviously are stored in long-term memory, but you would have no reason to really access them without the cue. First thing we're going to talk about is priming. It's an influence of one memory on another. Priming is implicit because it does not depend on awareness and is automatic. So many times it happens and you don't even know what's going on. We all do it. Here, the following is an example, and I love this one. Okay. All right, so you're going to unscramble the following words. Just take a look at them, and I'll give you a couple seconds that you can see a bunch of scrambled terms, and normally I would have the answers right off to the right, but I'm not going to do it that way here. I will go to the next slide. And here we go. You can see first one is rose, and then petal, and then stalk, stem, blossom. Okay, there's a theme here. I don't know if you caught it, but the terms have to do with a flower. So that last one, for those of you that did not kind of get this, what would the last one be? And I'm guessing most of you would say leaf. And you wouldn't be wrong. There's a lot of different ways to interpret all those words. But because you had been cued or primed for the words that deal with flowers, most of you probably came to the conclusion that it was leaf, not flea. You wouldn't be wrong either way. It's just the fact that you were primed. And that's all I'm trying to show you there. All right, here's another one. So take a look at this picture. Okay, and now I'm gonna say a word, and you write it down or spell it in your head. You don't have to write it down. I wouldn't know anyway because I'm not there. So the word is hair. Most of you probably wrote the word H-A-R-E because I primed you to write hair by showing you a rabbit, which is H-A-R-E is closer to the rabbit than H-A-I-R. Okay, although had I shown you a picture perhaps of somebody cutting somebody else's hair or a haircut or something, you might have more likely written H-A-I-R. So again, there's always the oddballs out there that may not do it that way and not see it that way, but I'm just trying to point out here that you can be primed. All right, now we're going to continue on with retrieval cues. Now you got déjà vu, which is French, and it means literally means I've already seen this, like I've already been here. But an eerie sense that I've experienced this before. Do not worry, you are not time traveling. It's not possible as far as we know. Cues from the current situation may subconsciously trigger retrieval of an earlier similar experience. So you may be in a certain, I don't know if it could be a room, it could be a social situation, it could be a lot of things cueing you to go grab memories that you hadn't seen in a long time or experienced, and they start coming forward, and it gives you that eerie feeling. That's the best we got as far as a theory today for déjà vu. Mood congruent theory, okay, or mood congruent memory, I'm sorry. This is saying that the tendency to recall experiences that are consistent with one's current mood. So if you get in a bad mood, it's kind of how things can spiral out of control. You're in a bad mood, and all you think about is how bad everything has been and how bad your friends are and how teachers don't like you and how your grades are bad. That can actually keep pulling all the negative memories forward. So you have to, sort of cognitively find a way to get yourself out of that funk and say, I'm going to stop this thinking right now, and I'm going to start thinking more positively. Easy to say, harder to do. Okay. So again, memories, emotions, or moods serve as retrieval cues. And then it even goes into things. You can even get into the best way to take a test is to actually study in the mood you were in, or to take the test in the mood you studied in, or even the best or even take the test in the exact place you studied in. Unrealistic. You can't actually do that. You can't sit here in the classroom all night long and study here at your desk for the AP psychology test I'm going to give you on memory, but in theory, that would be the best way to do it. Now we're going to talk about forgetting theories. How do you forget? 3 big ways. You don't encode it. Time plays a big factor. And then you have interference. So here's our little chart again that shows us how information gets into our skulls, into our brains. And as you can see, it starts to external events. It moves to sensory memory, goes to attention, then short term, and you work with it. It goes into to start to be encoded, and right here you see this block. It's stopping it from getting into long-term memory. And there's a variety. It really has to do with the amount of attention that you tend to pay to it. You think you may be paying attention to certain things, and you really aren't. And I have some examples that follow that really will stand out as to, aha, I see what you mean by not paying attention. So, just sitting there without looking, what are the letters that accompany the number 5 on your telephone? For most of us, I don't have any clue. Maybe in the world of texting it's a little bit different. I don't know. Where's the number 0 on your calculator? That one always seems, you guys seem to know where that is exactly, but I never do. So according to this theory, objects seen frequently, but the information is never encoded into long-term memory. Okay, and here's another example that will really bring it home. Which penny is the real thing? And I know this was in the book, but I'm sure you did it, and you're looking at all these pennies, and you're like, you gotta be kidding me, they all look so similar. And we've held hundreds, if not thousands of pennies in our hands over our lifetime. How many of us really know if we're holding a real penny or a fake one? I wouldn't know. And the same is true for any money, a nickel, dime, quarter, dollar. But we use them all the time, but we just don't encode everything about it. And the answer here is, of course, A is the real penny. All the others are somehow different, fake. But you probably read that in the chapter already. Here we go. Time. Memories fade away or decay gradually if unused. Time plays a critical role. Okay, so you encoded this information at one point, but you have little reason to keep connecting back to it, and so literally, remember we were talking about synaptic connections is what seems to be what creates the strength of a memory. The stronger the memory, the more powerful the memory, the stronger the synaptic connection. But in this case, you just don't use it, and so that synaptic connection starts to fade. The example I would give is, I can't remember. I'm sure I had a best friend in 2nd grade. I moved a lot when I was very young, so I didn't tend to stay in a place very long, so I didn't grow up with the same people. And so I might have had a friend in 2nd grade, my best friend, I guess you could say, and I'm sure I knew his name or her name. I have no idea who it is. But then my family probably moved away very quickly, so the kid was sort of out of sight, out of mind, and I never had a reason to retain that information as I moved on to 3rd and 4th and 5th, and very quickly it was just gone. And today, thinking back on it, I have no idea. I would never know. Have no clue if somebody said, oh, your best friend was, Jacob. And I'd be like, you got me, geez, that's a new word to me, because there is virtually no memory there at this point. Here we have a chart that just shows rapid forgetting of some information relatively soon after Ebbinghaus learned the nonsense syllables, and very little memory loss of the remaining information over the course of the following several weeks. So there is a point at which we tend to retain a certain amount of information for a fairly long period of time, and then of course it will gradually fade away. That's the only point of this. Here, another graph of storage decay, of lists that are retained, and time in days since learning the list. And again, it shows that as the days go on, you retain less and less, and it does begin to plateau out, and it slowly decays after a certain period of time. Another example of learning Spanish, of how much do you lose of your vocabulary after, as that looks like about 3 years, then 5 years. It seems to be a resurgence a bit, but anyway, for some reason it levels off somewhere around 5 to 9 years, and you just sort of retain a certain amount of Spanish, if you don't have a reason to use it, that you probably won't ever forget. All right, forgetting can result from failure to retrieve information from long-term memory. So now I'm going to stop here, and then I'm going to start the next screencast right here.